let's get started. So I'm sure there'll be more people trickling in. I know the keynote ran just a little bit over, but let's get started. So what we're going to cover today, I'll start with a very brief orientation, and then we'll spend most of the time talking about roles for EC2 instances and EC2 resource level permissions. I will briefly preview another feature that's coming out soon, which will be resource level permissions for run instances. We'll spend a little bit of time on how to debug some of these policies, and then I'll provide some additional resources at the end. We won't have a Q&A session here, but I'll be happy to take some questions afterwards. And then Ken, if you want to stand up. I'm on the EC2 team. Ken is on the IAM team, and he will be happy to take your questions as well at the end. So the types of problems we're working on here are primarily credential management and authorization problems. Who can do what types of problems, as well as how do I get credentials to them. We're going to often talk at the API level here because a lot of these permissions are enforced at the API level. It works equally well in the console and through the tools. So please understand that even though we're talking at the API level, it doesn't mean that this is just for the APIs. The consoles and tools are using the APIs themselves. So this is the lowest common denominator that we often speak in here. We're going to assume a little bit of prerequisite here. I'll try to keep it to a 200 level class. If you have ninja questions, come find me at the end. We're going to assume that you have some basic familiarity with IAM and EC2, but we'll not assume that you're necessarily an expert in it. And we're going to take an admittedly EC2-centric view here. So a lot of these same topics work for other AWS services, not just for EC2. To simplify things, we're going to talk primarily about the EC2 version of these subjects. So roles for EC2 instances. First of all, what is a role? A role describes a set of capabilities. It can be assumed by a user. It can also be passed to an instance. And the passing it to an instance is the case that we're going to mostly focus on here. A user can only assume one role at a time. It's exclusive, so I can't assume two roles at the same time, which is a nice effect for certain permissions. If you have somebody, for example, that has multiple different roles in your organization, you don't want them to be able to mix those. Maybe they're a DBA and they're also a web engineer. Roles provide a good way to make sure that they're only acting in one capacity at a time because of that exclusivity. Role permissions are established by IAM policies. We'll talk quite a bit about that in the resource level permissions section. Roles have preset expiration times, which is kind of a nice feature in a lot of cases. So when you assume a role, it's for a session, and that session expires at some point. After the session expires, the credentials that are associated with that role are no longer valid. And credentials are, roles are, of course, a great way to manage permissions. So what's a simple example of this? Maybe I create a web administrator role. I give the web administrator role permission to run and terminate web servers. Maybe there's more to it than that, but in a simple case, maybe that's all it is. I'm going to then grant several users permission to assume the web admin role. These users can now assume that role, and once they've assumed that role, then they can start and terminate web servers. They have the capability now of that role after assuming it. So that's all well and good. That's the normal user case. But what about a programmatic user? So suppose I have an application that needs to be able to do something. One common anti-pattern, and you should not do this, but one common anti-pattern that people sometimes are tempted to do is to create a user with long-term credentials associated with it, and then save those credentials somewhere that their program can access it, maybe in a file, maybe you check it into your source code, maybe you do something insecure with those credentials, so that your application can then use the permissions of that user. You should not do this. There's better ways to handle that. And the better way to handle that is to use a role with an instance profile. So when you use an instance profile, what it does is it delivers the role credentials to an instance for you automatically. In addition to being delivered automatically, they're also rotated for you automatically. So I mentioned before that roles have an expiration time. Prior to the role expiring, the instance profile will produce a new set of credentials for the role. So it's rotated, the standard I believe right now is every 6 hours. And so on a regular cadence, you'll get a fresh set of credentials associated with that instance profile. You don't have to actually deploy any credentials in this case because it's already deployed for you to the instance. So you don't have to check anything into source code. There's no file with secret key material in it that you have to manage. That's all provided for you. Another nice feature about this is because you're actually applying that through the APIs, you can actually now look at the instance and see which instance profile is associated with that instance. And that allows you in turn to understand what permissions have been granted to that instance from an API level. You don't have to necessarily log into that instance now to know what permissions have been deployed to it. So you get a lot of improvements in visibility as well. So some common use cases where this comes up. Maybe my instance needs to be able to access an S3 bucket. Maybe it needs to access an SQSQ, maybe an SNS topic. This could be as simple as uploading its log file. It could be something richer than that. Maybe I need a cron job that's going to take regular backups for me. Maybe I have a chef server or some other sort of management server that needs to be able to do some things in my environment. I need to give it permissions to do that. Maybe I'm doing something creative when I'm bootstrapping my instance and it wants to describe itself to understand whether it's in a beta environment or a production environment, and then it's going to do something different as it bootstraps itself. This is a good way to enable it to do that without having to deploy credentials for each individual instance. So how can I do this? First of all, the first step is to create the role. We can watch how this works here. So I'm going to go to the IAM console. Presumably most of you have seen this before. I'm going to log in. I have MFA enabled, so I'm logging in with my MFA. All right, now I'm going to go create a role. And here we're going to create an Amazon EC2 role. You notice that other services also use roles. And we're going to give a read-only role here. So it's very simple. This role is going to enable the instance that it's deployed to be able to describe resources, but not to mutate them. So I'm going to go ahead and set this up. And now my role is created. And if I want, I can go look at all the policies that are associated with this role. If I ever have questions later about what it's able to do. And then this trust relationship, I can see here that I've trusted Amazon EC2 with this role. So this is the way that I can tell that EC2 is going to be the service assuming this role. And I can see some information here in the summary. I will actually use that instance profile, the instance profile ARN. If I am at the API, I use that to actually pass that to the instance when I run it. We'll do it through the console, which will be a little easier to see. So now I'm going to deploy this role to an instance. So to do that, I'm going to go to the EC2 console now. And there's a couple different ways you can do this. I'm going to use the big blue button on the dashboard. And we're going to run a Amazon Linux instance. This comes with the tools and SDK already installed, which makes for a nice demo. And this is the critical step here. Under the configure instance details, we're going to add an IAM role here. And this is the role that we just created. Now I'm going to do something a little bit naughty here and use a security group that's open to the all IP addresses because I'm on Wi-Fi when I'm doing the demo. But normally if you have a corporate network, you can also restrict this so people can only SSH in from a limited set of source IP addresses. And I'm going to review this, and I'm going to see at the end here, I can confirm that my IAM role is going to be added to this instance when it's run. I'm going to go ahead and launch it. And it's as easy as that. The instance is now starting, and it will have the role on it when it's available. I can go look at it here. And there it is. This is the instance that I just created. And then if I come back to this later, I forget what I did, I can also come to the instance page here, and then I can see again that the IAM role is deployed to this instance from the instance details here. So this is all well and good. Let's see what we can do with this now. So now that the instance is running, I'm going to take the public DNS here, and then I'm going to SSH into this instance. Apologies to Windows users. There's an analog in Windows as well. I find the Linux-based interface here pretty clear. So I'm going to use my private key pair here to log in. This is the instance that I just created. So I'm logged into this instance now. I'm going to configure my region for the AWS CLI quickly, just so it knows which region to use. I'm doing this in SFO, in the US West 1 region. And now I'm just going to call describe instances. I haven't done anything with credentials myself. I haven't touched any secret key material. And I was able to just describe all of my instances in this region from this instance. And just to prove that the role is actually using the permissions that I deployed to it, I'm going to now try to terminate an instance. And you remember I gave it a read-only role, so it should be able to describe resources but not mutate them. So I'd expect the terminate instances call here to fail, because I did not give it permission to do that. And sure enough, that does fail. So now I've just managed to deploy an instance that has permissions associated with it as if by magic. And I log into it without touching any key material, and I can make API calls now or use the CLI here. And the way that this magic works, so that you guys have some background on this, there's actually a URL here, this 169.254 address, that is only addressable from inside of the instance. And this is the instance metadata. And this service actually has quite a bit of information in it. IAM credentials is one of these things. I can see here that I have my role is deployed to this instance. And now I'm going to go pull up the actual credentials for this role. And you can see there's actually a document here that I can only access from inside of this instance. It's got an access key, it's got a secret key, and it's got a token. And these are the credentials that I'm using to make those API calls. Now, the AWS CLI has automatically pulled those in for me, so I don't need to do any work. If I'm using third-party tools or I want to roll my own, I can actually just get this JSON document, parse this myself, and then use those credentials to then go make my API calls. And there's an expiration time here as well, and this is going to rotate on a regular basis. So, as if by magic, a couple more details here that are interesting. So, these are automatically available through the instance metadata. You'll want to look at that URL. That's all in the IAM documentation. You can use these to make API calls, and it saves you from doing dumb things like checking in your secret key, taking dependencies on that. So please don't do that. A couple additional considerations here to be aware of. Any process or user on that instance that's able to access that URL can get to those credentials. Those credentials are role credentials. So if I'd done this just recently and those credentials were still valid and somebody could type quickly enough, you could type that and then you could make API calls using my account. So you want to make sure that you control who has access to that instance. So if you're going to let people SSH into this instance, you're going to deploy that role, you want to make sure that you're controlling, in most cases, the best way to do it is not to let anybody into that instance unless they should have access to those role credentials, which means that you have to own the control around the access to that instance. Another thing that's a fine point, but the one that you'll probably discover very quickly, these roles can be added to instances at the time that you run them, but they have to be added at the time that you run them. You can't add it to an already running instance, so make sure that you're adding that when you first run the instance. Now, you can change the permissions later, and that's very easy to do, but you want to make sure that the profile is deployed at the time that you run it. And then a quick word on some of the other uses for roles. So roles aren't just interesting for instance profile use cases. You can also use them for other identity and access problems. So for example, one of the things that you'll see with some of these other services like Elastic Data Pipeline, Cloud HSM, they're actually using roles in your account, and that's how you're actually permitting those other AWS services to take actions in your account. This is actually a good practice, not just with other AWS services, but if you have other third parties that you're working with, roles can be a good way to describe a set of capabilities that you want that third party to be able to do in your account. And it's a very clear contract around what they can and can't do. Roles also support cross-account access, and that's another very powerful tool here as well. So outside of the instance profile case, I can allow somebody using another AWS account to log in with their normal AWS credentials from their home account, and and then assume a role in my account when they need to go do something in my account. So this can be a great way to work with vendors and third parties using roles. And then you can also use roles with web identities. So this is your Facebook login, your Google login, your login with Amazon. You can actually pass role credentials to individuals and users that have logged in with those credentials as well. So let's talk about resource level permissions now. So we've talked a bit about roles, which helps me manage identities and get secret material out to the instances. But that read-only policy wasn't very interesting. I don't think people would be coming to a session at reInvent if all you wanted to do was a read-only policy. So let's talk about how we can construct a little bit more interesting policies here. So resource-level policies are actually available for quite a few AWS services. You probably saw the DynamoDB announcement recently, which is quite exciting. We're going to talk specifically about the Amazon EC2 implementation of this, but recognize that a lot of these same ideas will apply to other AWS services as well. So what we're talking about here are the ability to write IAM policies that have fine-grained permissions that allow access to individual resources or sets of resources within a larger environment. And one of the cool things that we do with resource-level permissions for EC2 is tag-based permissions models. So we'll have a couple examples of this. So you'll see very quickly that if you are one of the customers like you saw in the keynote where you have thousands or tens of thousands of resources running, writing policies for each individual one is probably not a practical solution. So what we enable you to do is to tag those resources and then write policies based on the tags that are present on those resources. And you can use this with any IAM principle. So you can use this, you can apply these types of policies to users, to groups, to roles, to any new thing that IAM might invent in the future as well. So a couple sample use cases when you might think about using this. Maybe you have a user that's supposed to be able to start, stop, terminate, take other actions on a very limited set of resources. It could be an individual developer, it could be a team, a group of people that you want to give control over certain resources to, but not others. This can be other actions, for example, like attaching volumes. These can be multiple resources involved in these actions. They don't have to necessarily be atomic. Maybe you have certain people in your organization that you want to perform certain activities, like managing security groups. You want to delegate to a group of administrators. You don't want to trust your end user maybe to make security group changes. Maybe you want to set up like a dev environment and a prod environment. You're going to be more permissive in your dev environment than you are in your prod environment. This helps you do that. Maybe you have certain very sensitive resources and you want to require MFA to make changes there. So this could be a change to authorize access on a security group. This could be something very impactful to a VPC. This could be an action on a production database that's very sensitive. And you can do things like require any action on that resource, use an MFA device, which you can then keep in a safe under a director's desk or something like that if you have other sorts of controls that you want to implement. So how does this work? So what we're going to do is we're going to construct special IAM policies that have these fine-grained permissions. And then we're going to take an IAM principal. We'll use Bob for this example. And we're going to give Bob permissions to do different things. He's going to be able to do the things that we've allowed him to do by this fine-grained policy and not other things. This is all going to be enforced at the API level on the back end. So this is enforced at by the EC2 APIs. Now, any other tooling that we might have, be it the console, be it the CLI, be it third-party tools, will all use the EC2 API, so that's the least common denominator. But this will work regardless of how somebody accesses this. And the policies are all going to result in either allowing Bob to do something or denying him the ability to do something. There's really no other possible outcome. It's either permitted or not. It's totally binary. So let's do a very simple example. We're going to let Bob stop one instance and not any other instances. How do we do that? So first of all, an administrator is going to add a resource level policy to Bob that's going to enable him to stop one particular instance. We're going to take advantage of the fact that IAM uses a default deny model. So anything that Bob is not explicitly given permission to do, Bob will not be able to do. He has to be explicitly authorized to do something, and he can't ever be denied the ability to do it in order for us to authorize him. The model is you need at least one allow in the absence of a deny is the easy way to think about this. So we're going to give him one allow, and then we're not going to say anything else about anything. It's often very complex to write policies about all the things Bob can't do. So we'll merely write a policy about the one thing we want Bob to be able to do. So in order to do this, we're going to go into users. I've created a user Bob here already. And there's no permissions associated with Bob yet. So we're going to attach some permissions. We're going to use the policy generator. The policy generator is one of the better ways to create resource-level policies. And this is going to be a policy for Amazon EC2. And we said that we want Bob to be able to stop an instance. So we're going to give him permission to the action stop instances. And then we're going to use an Amazon resource name here. This is a scheme for uniquely identifying Amazon resources. You can see there we've got an individual instance that we've named there using that ARN. We'll give you more information on the documentation for how you can learn more about how those ARNs are constructed. But suffice it to say there that Bob is going to have permission to stop this instance ending in 22F, but nothing else. So once this policy is applied, let's see what Bob can do. We're going to test the policy. We're going to have him try to stop an instance, which is the one ending in 22F there. That's going to succeed. And then we're going to try to stop another instance and make sure that that fails. So to do this, we're going to use the AWS CLI here. So that's the instance ending in 22F that we just gave Bob permission to stop. We're going to take advantage of this nice feature that the AWS CLI provides where it allows me to have multiple identities. So I'm going to make this API call as Bob. I've already put Bob's credentials in here. And you can see that Bob was just able to stop that instance. So that worked as expected. Now we're going to try to stop a different instance. And we haven't said anything about whether Bob's allowed to do this or not yet. So we're going to use the default deny here to prevent Bob from doing this. Again, making this API call as Bob. And sure enough, Bob's not able to do that. So we've had a simple policy there, kind of your most limited example. We've enabled Bob to stop this one instance and not to stop another instance. Now, suppose I don't have just 2 instances. Suppose I have hundreds of instances. I don't want to have to write a policy for each individual user for each individual resource. That's going to make me go crazy very quickly. So instead, I'm going to allow Bob now to stop instances with the tag stack equals dev on them. So if the instance has that tag, Bob will be able to stop it. Now, suppose I also have instances with the tag stack equals prod on them. I could choose to still rely on the default deny model and not say anything about that. Bob would not be able to stop instances unless they had the stack equals dev. But maybe I have number of people maintaining policies here. Maybe I want to be absolutely certain that Bob can't touch anything in my prod environment. I'm going to, in this case, specifically prohibit Bob from taking any actions on resources that are tagged with stack equals prod. So here I've got 2 instances, one that's OK for Bob to stop and one that's not OK for Bob to stop. You can see that we've got a stack tag there, where stack equals prod for the one that is not OK for Bob to stop, and stack equals dev for the one that is OK for Bob to stop. And it's still that same 22F instance that he's going to be able to stop, the one ending in 22F. Great. So now that we've seen that, let's go to IAM and let's set up the policy for this. So we're going to go back to Bob, and we're going to blow away these old permissions here and add some new ones. We're going to use the policy generator again like we did before. Again, it's an Amazon EC2 policy. We're going to do stop instances again. And then for the Amazon resource name here, we're going to do something a little different. So before we had a unique identifier for the individual instance. Here we're going to take advantage of the fact that we can use wildcards in these ARNs. And we're going to allow, instead of referencing the individual instance, we're going to use a wildcard to reference all of the instances in this region. So this is US West 1, and then that's my account ID, and then I'm going to do the resource type here, which is instance, and then /star, which will encompass any individual instances in that region for my account. And then I'm going to add a condition here, and the condition is how I'm going to reference the tag. So when it's doing the evaluation, it's going to be checking this instance, the additional information about that instance, including any tags on the instance, including what instance type it is, including what the root device volume is. All sorts of other condition keys are available to me here. The one that I care about is that the stack equals dev tag is present on that instance. Now, the condition prefix there doesn't particularly matter here because the key stack will be unique for the resource, so I can actually pick either one there. And so now I've got my allow policy, and we said we were going to do an explicit denial for instances with a tag stack equals prod on them, so we're going to do basically exactly the same steps here, except for the other tag. So EC2, stop instances, using the ARN with the wildcard. This will be the stack equals prod tag. And I want this to be a denial policy, so I'll make that the effect of that policy deny. So now I've got a two-statement policy here. One allowing him to stop instances with the tag stack equals dev, one denying him the ability to do it stack equals prod. I can see the actual policy document that's created by that policy generator here. Verify that everything is as expected. Great, now I've applied that policy to Bob. If I ever forget later, I can come back and just show that policy and see all the details here. Great, so now that that's been applied, let's do exactly the same thing that we did before, and we'll prove to ourselves that this works doing the tag-based policy. So Bob's going to now try to stop that one instance ending in 22F that has the tag stack equals dev on it, and that's going to succeed. And he's going to try to stop the other one, and that's going to fail. But in this case, we haven't said anything about individual instance IDs. We've done it purely based on the tags that are present on the instances. So I'm going to stop instances again. And depending on your environment, obviously, you may have more than just dev and prod. You may have a series of different cost centers or applications. If you want, you can actually get more complex here, and you can require the presence of two tags. So maybe Bob is only able to act on the DB tier in your dev environment, but not the web tier. So you can apply multiple tags and make this as complex as you would like. You'll find the complexity of implementation scales roughly in line with the complexity of what you're trying to do, hopefully. And so, of course, the first one here worked as Bob, and then we expect the second one to fail. And of course, that fails as expected. So let's talk a little bit about how IAM policies are structured. So I kind of waved my hands a little bit at that big JSON block before that was the actual policy document. So let's talk just a little bit about how that's composed. IAM uses what we call the PARC model. And PARC is an acronym here where P is for principle, A is for action, R is for resources, and C is for conditions. There's a couple other minor pieces in the policy, like there's a version number, there's that effect, allow, deny. But the meat of the policy are really these four items. The principal here, in this case, Bob was the principal. We don't actually see Bob in that policy that we created because we're attaching the policy to Bob. So the fact that it's a policy about Bob is inferred from the fact that the policy was attached to Bob. Typically, when you add policies in IAM, you will not actually see the principal in the policy statement because you have applied the policy to the principal. The action is the action that is going to be performed. It'll typically map very closely to API level actions. So in the case of EC2, it's almost a one-to-one mapping. There's a few cases where the action is subtly different than the API that it refers to. An example would be for security groups, there's a separate action for allowing ingress versus egress, whereas there's a single API, but it's usually pretty high fidelity relationship between these actions and the APIs that you're going to allow them to call. Stop instances was the example we just saw. The resource is a resource that's involved in the action. It could be an object of the action. It could be, in a grammatical sense, a direct object. It could be an indirect object. And this is something where it's going to depend a little bit on the specific action that you're using. So we'll see an example in just a second where there's multiple resources involved in an API call. You will need to separately authorize each of those resources in the case where there's multiple resources involved. In this case, we had a simple example where we were authorizing this individual instance. And then conditions are optional. You don't necessarily need a condition statement in a policy, but it allows you to further limit what's going to happen by the policy. These are optional additional parameters. You can see there that we use the EC2 resource tag stack equals dev as a condition key. And that was so we were allowing access to that instance conditional on the presence of this tag on that instance. There's a number of other conditions that are available. The platform-wide, there's a number that AWS provides through IAM, such as MFA access, the source IP address, generic cross AWS items, as well as a number of specific EC2 items, such as the resource tag here, and then other attributes typically related to the resource that we're evaluating in the policy. So then these then get combined into a policy statement. Here's a kind of a pseudo policy here. We would also typically have a version number in here, but we omit that for simplicity. We have an effect, which is going to be allow or deny for a particular action on a particular resource subject to certain conditions. This would then be attached to the principal that it's going to be applied to. In terms of how all of this works, all of these policies are provided by IAM. It's a central cross AWS service. They are then implemented by the individual service teams. So the examples that we've been seeing, we've been switching between the IAM console and the EC2 console. EC2 here, for example, enumerates all the different actions that are provided and the different resources that they can act on. So usually when you're working with these, you'll want to look at IAM documentation. Practically what this means is look at IAM documentation for things about managing policies, uploading them, that type of information, and then look at EC2 documentation for information about which actions are supported for EC2, which resources they're acting on, what condition keys might be available in that context. So you'll usually need to look at both. So a minute ago, I promised a little bit more complex example that would involve multiple resources. We'll do a slightly more complicated one here, where we're going to allow Bob now to attach a volume to an instance. It actually acts on both resources. Depending on the context, I might care about whether Bob is allowed to attach volumes to the instance, or I might care about what instances Bob is allowed to attach that volume to, depending on my use case. So maybe there's something sensitive about that instance. Maybe there's something sensitive about the data. I want to make sure that I'm actually controlling both of those in this case. In order to do that, I'm going to actually write a policy that allows Bob to attach the instance and the volume only if both of them have that stack equals dev tag on them. So I'm going to do a policy evaluation against both resources here. So because this is a little bit more complex action, and this is a good general practice, we're going to actually start by consulting the documentation first, just to make sure that we understand exactly how this is going to work. So this is basically where you're going to want to go for learning more about specific and more complicated actions. You want to go to the EC2 API reference, and then there's this permissions section here. And you can see that we've got documentation on the different actions that are supported here. I should point out that not all EC2 actions support resource level permissions at this point. Describe instances being, for example, a notable absence. So you'll want to make sure that this is supported for the action that you're using, because it is only a subset of APIs at this point. So we found attach volume here, and we can see that attach volume uses two resources. There's an instance and a volume that we'll need to authorize. And in both cases, this resource tag is supported for both resources. You can see that there's some other condition keys that I could choose to use there as well. So maybe I care about authorizing Bob's access to that volume based on the parent snapshot that it was created from. Maybe in another context, I might care about information such as what instance type it is, things like that. So I can see all the information that's available to me there. My use case is supported, so I'm good to go. So now I'm going to go ahead and write this policy. So I'm going to go back to Bob here. I've deleted his policies again, so we're going to add new policies for Bob. We're going to go back to this policy generator like we did before. Again, it's an EC2 policy. And the action here that we're going to use this time is attach volume. Right, and then we're going to do the ARN with the wildcard like we did before. And I'm going to paste it in here to save time. So this is the instance policy. Now I'm going to add conditions. So again, we're going to do the tag-based policy. Now we're going to do a second statement here for the volume. Now, if we wanted, we could do different policies for the instance and the volume. So maybe I have a different tagging scheme for the instances than I do for the volumes. You know, maybe sensitivity equals low on the volume or something else, depending on what's relevant to me. I can also use variables if I want. So I can tag the volume with Bob's username and then only let Bob touch volumes that are tagged with his username if I want to be a little bit more complicated. Lots of ways to extend this here. But we're going to keep it simple for now, and they're both going to have stack equals dev on them. Great. And now we've allowed Bob to attach instances with that tag on them, and we've allowed him to attach volumes with that tag on them, which will now allow him to accomplish his use case. Check the policy. That's all good to go. Wonderful. We can verify that later here if we need to. So let's verify that this actually works as expected. And we're going to try a couple permutations here. So first of all, we've got two instances, one that's that development instance from before and one that's a production instance. We're using the tags screen to see this here, which is in the EC2 console. So if you start using tags pretty heavily, this is a useful way to visualize that. Now we've got these 3 volumes, 2 of them are in dev and 1 of them are in prod, and we're going to do a couple different combinations here just to see that this actually works as we expect. So Bob's going to try to attach the volume. He's going to use this instance that he is authorized to use, this 22F instance. And then he's going to use one of these dev volumes. And that device there is just where we're going to mount the volume on the instance. And we're going to make this call as Bob. And sure enough, that succeeds because he's authorized to perform that action on both of these. Now we're going to try this again with a slightly different permutation here. We're going to use the other instance this time. This is the instance with the prod tag on it, so Bob should not be able to do this. Now, to keep things interesting, the volume that we're using is a volume with the dev tag on it. So Bob should be able to attach this volume to instances, but he should not be able to attach the instance to volumes. Because he's not allowed to do this, it doesn't, well, so we'll use the correct profile here. So because he's not allowed to do this, it fails. We'll try this the other way around now. So we'll use a instance that he is allowed to use and a volume that he's not. And again, this will fail. And sure enough, that also fails. So Bob can only attach the instances with a particular tag on it, and he can only attach volumes with a particular tag on it. So he needs to make sure that he's using an instance with that tag and a volume with that tag. There are other examples where this gets a little bit more complicated. We'll preview run instances very briefly in a second, which is something that's not out yet, but coming very soon, where this is going to be a little bit more involved. And here we're going to now again try to that he is allowed to do, just to prove to ourselves that this is working as expected. And sure enough, that works. So for these policies, a couple of best practices. The first one is stop and think about what you want to do here. So these are fundamental building blocks. You need to figure out what security policies are going to make the most sense for you, what model you want to use. And the first step for that is usually thinking about how you want to organize your users and your resources. So I used a very simple example here where we had the tags dev and prod. It's obviously a little bit simpler than probably the environments that most of you are working in. You'll want to make sure that you think through that. Do you want, for example, only one level of tagging? Do you want to also intersect, for example, application names or service tiers, different information like that for setting up these policies? Typically, tags are the best way to do this. You can use other things as well. Tags, you'll find, are the most flexible and most broadly available. Another good idea here, make heavy use of the default deny model in IAM. If you try to write policies that describe every individual thing that somebody should not be able to do, especially with the rate at which new features are arriving, you're gonna run into a lot of headaches very quickly. Much better to focus on giving very limited allow statements for what people should be able to do. Another thing too, these get pretty complicated as you get into more complex examples. Make sure that you're testing these to gain confidence in them. It's easy enough to fat finger something or whatever and have this not quite work as you expect. So make sure that you're testing these before relying on them heavily. A couple additional considerations here. So if you do use tags for permissions, you want to make sure that you're controlling who can actually apply those tags. So in these examples, if I gave Bob the permission to change that prod tag to a dev tag, I haven't effectively limited his ability to do very much. So I want to make sure that if I am using tags for this, that I'm thoughtful about who controls those tags. A little bit of a sharp edge here. Not all EC2 operations currently support this, so you'll want to look in that API documentation that we checked there to make sure that it's actually implemented for what you're looking for. One actually pretty cool benefit for this. So these same tags can be used for tag-based billing. So in a lot of cases, you may be wanting to set permissions based on what work group somebody's in, what application they work on. If you use tags for that, then you can go get detailed billing reports based on the cost of the resources with those tags on it. So you can set up one resource model with your tags and get both the billing features as well as the permissions features out of that. So we've got one coming soon announcement here for run instances. So run instances is going to support resource level permissions very soon here. And this is going to allow you to do a lot of cool stuff. There's actually a lot of different resources that go into run instances. It's one of the more complex APIs. This will allow you to control which AMIs and snapshots an individual user can use. So we can, for example, give Bob permission only to use AMIs that are on my corporate whitelist, or only a specific enumerated AMI, and that will be the only AMI that he can use to run instances with. I can control which snapshots he's able to use as well. I can do both of those with tags or individual resource identifiers, of course. I will be able to also control the types of resources that he can create using run instances. Most notably, this is the instance and the volume. So I can control, for example, Bob's ability to create M1 small instances. Maybe I want him to be able to do that. Maybe I don't want him to be able to create a new I2 instance at the moment, whether for cost reasons or because I don't think it's appropriate, whatever. I can specify the types of attributes for that resource that he's intending to create, and then have the policy allow or deny him to do that based on those attributes. I will also be able to authorize Bob to launch instances into certain subnets, but not other subnets. So if I have, for example, a production subnet and I want to make sure that that's only used for a production workload and Bob shouldn't be able to run instances there, I'll be able to prevent Bob from doing that. I will also be able to control which security groups Bob can use, which network interfaces he can use as well. So pretty rich set of permissions around the types of resources that Bob is able to create. I don't have an exact date to share with you for this, but it's coming in the very near future. And of course, there will be more after this as well. So the best way to keep an eye on this, we'll be announcing these, of course, in the forums, on the blogs, and then, of course, those documentation that we saw before will be updated as these are added. So, a couple months from now, if it's been a while since you've looked at this and you're wondering, check that documentation. It's very likely that there will be even more that we've provided here. So now I want to talk about actually what I think is one of the very cool features. It's also a little bit EC2 specific here for how you manage some of these complex policies One of the challenges, of course, is if I want to make sure that Bob isn't able to terminate my production database, the last thing I want to do is try to terminate my production database and then find out that that succeeds when I didn't intend it to. So we've got a feature for EC2 here that we call dry run API calls. And this is a flag that I can use when I make the API call. It will check the authorization result of the API call, but it won't actually process it. And this is specifically useful for this example. So let's watch how this works. I've changed Bob's policies around a little bit for this example. Bob's going to now try to terminate an instance. You can imagine that this has something on it that I don't want Bob to terminate. And I'm going to make sure that he cannot terminate this. So I go ahead and just like before, I'm going to try to make this API call as Bob, but now I'm going to add an additional flag here, this dry run flag. And I'm going to see now that that call would have succeeded. If I didn't have the dry run flag, it would have actually gone and terminated that instance. Thankfully, I used the dry run flag, so it's not actually terminated, and now I can figure out that my policy would have allowed that. I'm going to now check a different instance. Again, making the API call as Bob. And now this is the other possible result. So Bob was not able to terminate this other instance. And so I've used this as a way of figuring out the effective permissions that Bob has. This is using all the tags that are currently on those resources, all the other contextual information that might be there, just as if it was a real API call, except that I haven't actually processed it. The second really cool feature here, you've been noticing these big, ugly ASCII armored blocks that are called encoded error messages. These are actually a really cool feature that you can use for this. You have to be using a recent version of the EC2 API to get those. So if you aren't seeing those when you're using EC2, you're probably not using a recent enough version of the API. So make sure you're using at least the June 15th API or later. And then there's a relatively recently released STS API that you can use to decode these. It's called Decode Authorization Message. And the result's going to include a lot of information on what the user tried to do, and then what the result was. And you can lock down access to that STS API using IAM as well. So you can have, for example, an administrator that's able to decode these messages. The user maybe can't decode them themselves. They could email them to an administrator, for example, to have those decoded. So let's continue this earlier example that we just had here. And we want to figure out more about why Bob wasn't able to terminate that instance. So we're going to use this STS API here. And we're just going to copy and paste this whole block. And now in this case, I created a new user here called Alice, and Alice is my administrator. And Alice is going to check this. Bob would not be able to check this, but Alice can check this. And she's going to get quite a bit of information here about why exactly this was denied. And she's going to see that this was an explicit denial. So I had an actual denial statement, which is why Bob wasn't able to do this. And the denial statement here is a statement that does not allow Bob to perform any actions on resources with a prod tag on them. And then I can see information about the instance that Bob was trying to terminate as well. And I'm going to see down here that the instance that Bob was trying to terminate had this prod tag on it. And so that policy matched that instance that Bob was trying to terminate, and that's why he was denied that ability. This can also be very useful in contexts where you want to figure out what condition keys are available. For example, I can actually see a full list of all the different condition keys that are available to me when I want to write policies about what Bob can do with this instance. So I can see, for example, there's a region tag here, there's an availability zone tag here, there's an instance type tag here, there's an EBS optimized tag here as well. I can write policies to any of those. Typically, when I'm personally writing policies, I find it very useful to use this feature, and then I just copy and paste what's in here that I want to write a policy. So I don't add any policies first, copy and paste what I want in here into the policy, and it makes it a lot faster to author those policies. So putting this together, the best way to write these policies, if you end up in a position where you're doing this quite a bit, I typically like to start with a test user. So maybe don't use a real Bob, invent some sort of a test user where I'm going to keep their credentials so I can make calls as that user. Put a test policy on there, use that dry run flag, verify that you're getting what you expect. If you're not getting what you expect, use those authorization messages, decode those, figure out what's going on, iterate on that policy until you get the policy the way that you like it, and then go apply that policy to all the users, groups, and roles that you want to apply that policy to. So at the end here, a couple additional resources that you'll find useful. I'll leave this slide up for a second. There's kind of 4 main places that I would go for more information on this. I would go to the EC2 user guide, and I think that's the best place to start for all the topics that we just talked about. There's a section on IAM permissions for EC2, which goes through the actual way that you write policies. And there's a separate section on IAM roles, which goes through how you use the roles that we talked about at the beginning of the presentation. That's the best place to start. Links to everything else are from there. So if you're remembering this and not taking notes, start with the EC2 user guide. And then if you want to go into the actual API level details around what is and isn't supported, go to the EC2 API reference for that. There's a permissions section in there. That's the one that we saw in the video. And that has all the fine-grained details on exactly what I can do in which context. IAM also has some very useful documentation here. So they have a permissions and policies section, which talks in more if you want to learn more about the park model and how IAM policies are structured and applied. IAM has a lot of good resources on that. And they also have more information on roles if you want to learn more about some of the other examples of roles that we talked about, such as cross-account access, things like that. IAM has that documentation. And then if you're looking for good implementation ideas for this and good examples of how this can work in practice, use the AWS security blog for that. We're going to be periodically posting to that with cool use cases around different ways that you can take advantage of that, and that'll be a good avenue for this as well. In addition to, of course, all the normal avenues. So, you know, the EC2 forums, for example, are a great way to interact with us. The IAM forums, and we'll use, of course, the AWS blog and other resources as well. But specifically for this material, I think you'll find these most useful. So, with that in mind, we are wrapping up here. So we'd love to get your feedback on the session, what you like, what you didn't like. I guess there's a prize. I don't know what it is, but there's a prize if you fill out your survey. So take advantage of that. And thank you very much. Again, my name was Derek-Lyon. I'm a product manager on the EC2 team. So hopefully you found it helpful. If you have feature requests or questions or anything else, Ken and I would be happy to take your questions after the session. Thank you.